Mr. Minnick, helping my Java students with while loop worksheet number 1. Please read the directions closely, especially students that are coming directly from the Visual Basic class, because there are indeed some differences here between how Visual Basic handles things like the word not. In Java, it's, for example, an exclamation mark. That means not. In Java, the not equal to symbol is this right here, and not the less than followed by a greater than symbol. So read the directions. Okay, let's begin. In question number 1, we have what's called a declaration statement, and it declares the integer variable num and initializes it to 0. So please reflect that with a nice little 0 there. If you're using a stylus on your laptop, do what you have to make that nice and neat and small. Okay, we hit the top of the while loop. This is a control expression. The parentheses are required here, and we check to see if num is less than or 3. True or false? True. So we do go through the loop, and we do system out print the number 0 at this time, because 0 is currently stored in num, and system out print ln 0 causes that 0 to show up over here in my output window. The next line of code, plus plus. I know that did not work in VB, but it works in Java. It causes 1 to be added to the variable that it's attached to. So we cross this 0 out, make it a 1, and we go back up to the top of the loop. There's no phrase end while in Java. That was just a VB thing. In Java, we have this closing right-hand curly brace that matches up with the opening left-hand curly brace, and the result is that we loop back up to the top of the exercise there, of the loop. So we are at the top waiting for somebody to tell us whether the control expression is still true or false. It is indeed true. 1 is less than 3, so we go through the loop for another iteration. Because of the ln here in print ln, the num, which is currently 1, prints on the next line down. And we then num plus plus, it goes up to 2. We loop back up to the top. We check to see if this control expression is true or false. Well, currently num is 2, and 2 is indeed less than 3. So we do go through the loop again, and we system out print ln num, and num is currently 2, so a 2 prints out on the next line. And then we num plus plus, bump that up to 3, and we go back up to the top of the for loop. And this goes on and on and on until we get a false in the control expression. Well, let's check that control expression. Is 3 less than 3? No, it's not. So we finally achieved our false. We do not go through the loop, not even one last time for good time's sake. We just stop. There's no more code here to execute. We are done with this exercise number 1 code segment. This is your output, and this is the final value stored in num. I always like my students to circle that last number, even though it doesn't say in the instructions. Oh yeah, it does say, circling the last value, stored in the column for each variable. So there you go. Number 2, we have 2 variables. I'm going to do this one relatively quickly. Num is initialized to 10, dum is initialized to 0. Is num greater than 8? True. Is dum less than 3? True. And this is an and. It's in Java, the word and is typed with 2 ampersands. A true ANDed with a true does yield an overall true. So we do go through the loop here based on the truth table that we studied last year in Visual Basic. A true ANDed with a true is true. So we do go through the loop. Oh, we have a print here instead of a print ln. Well, that will come into play later. But right now we are printing the number 10, because that's what it says to do, print num. And num minus minuses, which means we subtract 1 from num. Dum plus pluses, so that means we add 1 to dum. And we hit the closing curly brace, which means to loop back up to the top. Carefully inspect the control expression to see if its overall is true or false. Let's check. Is 9 greater than 8? True. Is dum less than 3? True. What do you get when you have a true and with a true? A true. So we go through the loop. Now, print num. Because the print and not the print ln, num, which is currently 9, prints out on the same line, and Java does not embed a space there. So it looks like 109. To the person running this program, they think it's 109. And quite frankly, I don't care what they think. That is what prints out because of the code so far. And num minus minuses behind the scenes to 8, and num plus pluses behind the scenes to 2. We go back up to the top of the for loop for another go around, potentially. We inspect the control expression. Is num greater than 8? No way, Jose. 8 is not greater than 8. And when you have a false ANDed with anything, it doesn't matter what the anything is. Who cares? It's kind of like 0 times anything. Overall, it's false. Overall, this control expression is 0. Because AND, in the world of Boolean algebra, Boolean logic, is kind of like multiplying is kind of like multiplying. And you have a 0, which a false is really thought of as a 0. 0 times anything is 0. So who cares what num is? And we do not go through the loop anymore. We are finished with this exercise. Circle the 8, circle the 2, and 109 happens to be the output. Even though it was printed there in 2 parts, a 10 and a 9, it looks like 109 to people. Number 3, num starts at 1. Num less than or equal to 5, that's true, so we go through the loop. We system out print num, which is a 1, concatenated, that plus, just like in Visual Basic, means we are gluing together 2 things. Now in Java, you are allowed to take a number and glue it to a string. It just ends up looking like this, 1 minus something. We don't know, it's a hyphen. Minus what? Well, we don't know yet, because nothing else printed so far. But do notice this is a print. So the next time that we print something, it will show up to the right of the hyphen. Okay, num plus plus. It becomes 2. Then we loop back up to the top of the while loop. Gotcha. Nobody even complained here in this room. Make a record, year 2014-15, period 4, AP Honors Java class. Either students weren't awake or they just blindly believed and trusted their teacher. There is a mistake here. Can anybody explain, or are you going to let me have the glory of explaining the mistake to the people that are watching this video years from now? What did I just do incorrectly? Well, I'll tell you. I didn't use curly braces. When you have indentation in Java, it means nothing. It all depends on the curly braces. And when you have while loops with curly braces, like we did in exercise 2, everything's all happy, everything's happy, everything's good. We exactly know what lines of code are in the body of the while loop. But here, in number 3, in the absence of curly braces, the rule is that the next statement only is considered to be in the body of the while loop. So only system out print is in the body of that while loop. And num plus plus, even though it's indented, acts as if it's typed out over here. It really doesn't matter that it was indented. So think of it as if it looked like this. So we now loop back, well, we never num plus plus to 2 there. That was a mistake. Hopefully you weren't using pen. Num is still 1. We did print the 1 minus, but we now loop back up to the control expression and we check to see if num is less than or equal to 5. It is. So we do go through the loop a second time, and we do system out print num with another hyphen. And then we loop back up to the top of the while loop, and we check to see if this is true or false, which is still true. So we system out print num and a hyphen. We loop back up to the top. It's still true. So we print 1 hyphen, 1 hyphen, 1 hyphen. This never ends. We never get to the num plus plus. We never have a chance of this control expression becoming false. Num never hits 5. This is a logic mistake by the coder. The compiler does not catch this. This is not a compile error. Not with most compilers. It will not squiggly underline and tell you that you're an idiot. You just learn by yourself when you make mistakes like this, never to trust yourself nor your Java teacher. I've been known to make mistakes. And besides, up in the directions, I did allude to the fact that there could be an infinite loop on this worksheet. And you're supposed to write infinite loop where appropriate. So as your answer for number 3, you might just want to say something like etc., or just draw an arrow showing that you knew this continued, and just write, most importantly, write infinite loop, because that's the answer I was looking for. Obviously, the coder should have put curly braces on that original problem, but the coder didn't. It was sloppy. And he was misled by his indentation, and that doesn't work in Java. It does work in the programming language Python that's very popular, but this isn't Python, so moving on. Num was the final value there. It just never changed, so I guess I circle that if you want to be perfect. Number 4, sum is 0, while sum is less than 10. Well, 0 is indeed less than 10, so we do loop. Check this out. There are no curly braces. So I said the rule is, when there are no curly braces, the body of the while loop is considered to be the next single statement. Not the next line of code, the next statement. And statements are always terminated with semicolons. So this right here is considered to be the body of the while loop in exercise 4. Another infinite, no, it's not an infinite loop. Let's check it out. Because 0 is less than 10, we do indeed sum plus equals 2. In other words, we add 2 there. Just like in VB, the plus equals symbol works by doing that. We then loop back up to the top of the loop. We check the control expression. This is less than 10, so we do add 2 and go through the body of the loop again. Now nothing prints yet. There's no system out print in this loop. And then it goes up to 6, then it goes up to 8, then it goes up to 10, and we ask, is 10 less than 10? False. So we are now done with this while loop, and we execute the next line of code, next statement that happens to be in this program. Now, what moron indented this? Because right now, this sum plus plus isn't in the while loop. It should have been written out over here for proper style. Oh well, the person would lose a point on an assignment. But on the AP exam, they sometimes code things incorrectly or in misleading ways. So sum just plus pluses at this time. It bumps up to 11. And then we finally hit the line of code system out, print sum, and an 11 just simply prints out. 11 is the final value stored in sum there, and that's just the way it works. Finally, number 5. You can always watch this video over and over again to review, what happened in slow motion. Okay, number 5. Num is 0, dum is 8. And you are allowed to declare 2 variables in the same statement, setting them each to different values if you want to with this comma. I don't like my students to do that, but to save room on this worksheet and just to show you that it's legal, I did it. Okay, num is less than 3, so we set now dum equal to 8. Well, it was 8, but I still cross the 8 out and show it that it's still 8. And then I hit a new while loop that's nested inside of an outer while loop. Keep your focus here. A loop inside of a loop. So how does this work? Well, we check this inner loop. Dum greater than 2. Is that true? Yes, it is. So we do indeed go through the inner loop and iterate. We system out print 1 plus dum. Don't add 1 to dum and make it 9. This is not dum equals dum plus 1. This is just 1 plus dum, which according to order of operations, it evaluates and it temporarily becomes a 9 there, like you think of that as a 9. And what are we system out printing? A 9. Now do make a note, this is print and not print ln. And then we come to the next line of code, dum minus equals 2. This line of code, which can be thought of as dum equals dum minus 2, because in VB we did learn that that is what the minus equals translates to. Right now we're taking dum, which is 8, we're subtracting 2 from it. That simplifies to 6, and the 6 is being assigned and overwriting what used to be in DUM. It works, from right to left. So the bottom line is DUM bumps down to 6. And that's what that line of code, DUM minus equals 2, causes to happen. We now hit this closing curly brace, which sends us back up to the top of the inner nested while loop. DUM is greater than 2, so we do all this again. We do go through this inner loop again. I will speed up a little bit here. We print 1 plus DUM, so we print the 7, and the 7 does print right next to the 9 because of the print and not print ln. We subtract 2 from DUM, it's down to 4. We go back up to the top of this while loop. 4 is greater than 2, so we system out print 1 plus DUM, which means we print a 5. Interesting, we're printing the odd numbers, but DUM is taking on the even numbers. That's just the way it works. DUM minus equals 2, and 2 is not greater than 2. So we are finally finished iterating the inner while loop. We then proceed to execute this line of code num++. So num, who's been quiet all along, bumps up to 1. And we hit this curly brace. I like to do things like this. End of while loop, outer while loop. You might want to just code this way as a beginner. This right here was the end of the inner while loop. So I finally hit the end of the outer while loop, and that means I go back up to the top of this outer while loop, and I check to see if num is less than 3. Gosh darn it, it is. So I go through the outer loop again. DUM resets to 8. Oh, geez. DUM is back up to 8, but now AP exam takers, they see patterns. We know that DUM is going to go 8642, and we know that 975 is going to print again, all on the same line of code because of the print. And then we know that num is going to eventually plus, and we're going to go back up to the top of the outer while loop a third time, well, a second time back up to the top, for a third go around. 2 is less than 3, so we know that the DUM will reset to 8, and we know that it'll go 642 all over again, and that yet another 975 is going to print out. Eventually, num will then plus up to 3, and in this outer while loop, we will hit false, because at that point, 3 is not less than 3. So here's the final answer. Num ends up being 3. DUM ends up being 2, but it was only after tracing out all these numbers repetitively, 8642, 8642, 8642. And all this pattern repeats when it prints out, 975, 975, 975. There's your final answer.